Hey guys, this is Miss Mo. This is 11.4, geometry and three-dimensional shapes. So we're still going to be talking about the same things from 11.3, only now we get to talk about three-dimensional things. Okay, the first thing it says is pictured on the right are stacks of solid cubes. Determine the number of cubes in the stack and the number of faces that are glued together. Okay, so let's see here. If I outline this, you can see how many cubes are on not the front row, but the back two rows. So let's count how many cubes are on these back two rows. Well, let's count the top. We have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 cubes on the top row. Okay. What about this bottom row? There's still 8 cubes because they're stacked on top of each other. 8 on top, 8 on bottom. Okay. And then how many in the front? Oh, 4. Okay, so the question was, how many total cubes are there? Well, 8 plus 8 is 16, plus 4, 20 cubes. Alright, the next thing says, the number of faces that are glued together. Okay, so when we're talking about glued together, let's say I'm talking about these top 2 boxes right here. If I were to trace over them, they'd look like this. These 2 boxes in the top right corner. Okay, the question is, oops, sorry, you can't really see it. Those 2 boxes in the top right corner. Let's say they are these 2 boxes. Well, they're together, but they're glued together on their side. Kind of in between, they're glued together. Like that, okay? Okay, so that's one glue. Well, so are the 2 boxes next to those, and the 2 boxes next to those, and the 2 boxes next to those. So these 8 boxes are glued 4 times together. So this top row, these top 2 rows, they're glued together using 4 faces. So the face for the first 2, the face for the second 2, the face for the third 2, the face for the fourth 2. Okay. Then let's think about if they're stacked on top of each other, because we have a top row and a bottom row. Well, every time they're stacked on top of each other, their faces are glued together. There would be glue right here so that they could stay on top of each other. So we need to count how many tops and bottoms are glued together. Okay, well, let's think about this. In this top row, there's 8 boxes on top, there's 8 boxes on bottom, and if every top box has to be glued to the top of the bottom box, and there's 8 on top and 8 on bottom, that means they're glued in 8 spots. Okay, so that so in between that top row and that bottom row, they're glued in 8 more spots. So we already talked about the fronts of them, or the in-betweens. That was the 4. Then we just talked about them being stacked on top of each other. And stacked on top of each other means their top and their bottoms are glued together, and there's 8 of those. Okay, what else needs to be glued? So it looks like, oh, okay, so this top row, they're glued 4 times on the inside faces. So is that bottom row. They're glued 4 times on the inside faces. Then this whole top row is glued to the bottom row using 8 faces. And then the very last thing is this front row of boxes. How is it glued? Well, that front row of boxes is glued to the thing behind it. Using the front side and the back side of the front box. So this front row right here, it's glued to the back row in 4 different faces. So let's see, all together that's 4, 8, 12 plus 8 is 20 faces. Woo, that was kind of crazy. Okay, and again, if you need to make a box to help you, go for it. Okay, if we look at the next sucker, it says the figure on the right represents a card attached to a wire, kind of like this Starbucks straw and this note card. Okay, it says determine what the figure would look like if the card were revolved around the wire. Okay, well, let's see here. Here's the card, and if I revolve that card around the wire, what does it look like? Well, it looks like a triangle on the left. Heck fire, when I spin it, I still get a triangle on the right. Okay, so the point is, this 3-dimensional figure is kind of going to look like a pyramid or cone, where it's skinny at the top, fat at the bottom, as in a triangle. So C's out, because I don't even see a triangle on that picture. Okay, now let's look at this from the top. Okay, here's the top. Let's trace the bottom and see what shape it makes. If I spin my straw, the first time I did this, it looked like a potato. So let's see if mine looks better. Okay, spin, 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 spin. Okay, so as you spin this sucker, even though it looks like a triangle from left to right, when you look at it from the aerial view, it makes a circle as the base. So if we go back to our pictures, which one of these suckers has a circle as its base? Not A, because it has a triangle. Not C, because it has like a square looking thing. Yeah. But D, yeah, look at that D. It has a circle as its base. And then the sides look like that triangle. Yay! Okay, if you want to do it yourself, get a pen and tape a triangle card to it. Alright, the next sucker says, sketch a pyramid that is a hexahedron. Okay, pyramid means it comes up to a point, kind of like this A, this C, this D. Those come up to a point. All the sides meet at one vertex. Yeah. Whereas on this cylinder, the top is another circle. Okay, so pyramids should meet at a point at the top. So if we look at this picture, meets at a point at the top. All these sides meet at a point at the top. All these sides meet at a point at the top. Okay, so pyramid, yeah, meets at a point at the top. Hexahedron, that describes its base. So its base needs to have 6 sides. Okay? And the actual 3D figure needs to have 6 faces as you count around it. Well, look at this D. How many faces, or how many sides does the base have? 1, 2, 3, 4. That's not a hexahedron. That's called like a square pyramid. Okay, if we look at part A, let's see how many, I can't even really see the base, but let's pretend it's this guy. Okay, if this is the base, how many sides is that? That's 3 sides, so that's a pyramid, but it's called a triangular pyramid. So whatever your base is the descriptor for the pyramid. So if the base is a triangle, you call it a triangular pyramid. Okay, let's look at B. How many sides does B have on its base? 1, 2, 3, 4, 5. 5. Okay, that's like a, what's it called? Pentagon. Is a pentagon have 5 sides? Yeah, so it's like a pentagonal pyramid. Okay, let's look at C. How many sides does that base have? 1, 2, 3, 4, 5, 6. 6. Okay, that's our pyramid. That's a hexahedron. Yeah, so you have to count the base, the sides of the bases. Okay, if I were to count the faces, let's see if I can count the faces. I have 1 face here. Okay. I have 1 face here. Yeah. I have 1 face here. That's 3. Then there's another on the side, 4. And then I can't quite see the 2 on the back end, but I know there's another face for this top side and this right side. So even though I can't see 6 faces, maybe look for the 6 sides of the base instead. Okay, let's keep going. The next sucker says, give the tetrahedron, name the vertices, the edges, the faces, blah, 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 blah. Okay, well, first, let's start with the vertices. The vertices are where they meet at a point, where the faces or the sides meet at a point. So, for example, when we were looking at the hexahedron, the vertex was that very tip-top point that the sides met at. The vertex is also at every single point on the base where a new face starts. Okay, so let's go and find our vertices. Our vertices are the T, D, M, R. Yeah. Okay. Another way to say T, no, never mind. We'll just say T, D, M, R. Okay. Now it says the edges. Let's list the edges. To list the edges, we're going to use 2 letters at a time. So T, M, that's an edge. Then I have TD. Then I have TR. Okay, now let me do the bottoms. We have MD, MR, and not, let's see, DR. So these are the edges. And with these edges, it's okay to reverse the letters. So you could have, instead of TM, you could have MT. Or instead of TD, it could be DT. Or TR is RT. MD, DM. So you get the point. So you can reverse these if you need to. Okay, so we've done the vertices, the edges. Now it's time for the faces. Okay, for the faces, we describe them using all the letters. Okay, so let's say for this triangle on the right side, that's a face. Let's write down what he would be. He would either be TMD, or we could have maybe TDM, or we could have DTM. So with these faces, you can turn around the letters. It's okay. So you just have to follow clockwise or counterclockwise, like go in a circle. Okay, so we have TMD. Or we could have started at the M and said MDT. Or we could have started at the D and said DTM. Or we could go clockwise and say DMT. Either way, that's a face. Okay, now let's talk about another face. I see this face on the left. Okay, how do I label that? TRM. Okay, and again, we could write that several different ways. TRM, or I could go TMR, MTR, any of those. Okay, so I did the right and the left face. Now let's do, looks like this back end face. What would this back end be? That would be RTD or TDR, DRT, any of those. Okay, and I think your homework is multiple choice. Okay, so the only face we haven't done is the bottom of this, the base, what we're sitting on. Okay, and what we're sitting on is RMD. So we have 4 faces. Okay, now let's see what this hoopla is about intersection. Okay, it says the intersection of TMD, there's TMD, and RD. That line on the back. Okay, so it's asking what's the intersection of this RD and this TMD. Okay, well, this face on the right side touches that back edge at this vertex D. Okay, then it says let's find the intersection of face TMD. Oh, here we go. TMD and face TRM. Okay, so where do those touch each other? Well, they don't just touch each other at one single point at a vertex anymore, because on this last example we had a face and an edge, and they touched at a vertex. Here we have a face and a whole nother face. Well, where do they touch? Right down the center here. Okay, how do you say that center? You say T to the M. And these double letters, you can put lines on top of them to mean line segment. Yay! Okay, let's keep going. Let's look at this sucker. I went ahead and copy and pasted it because it's kind of crazy. Okay, it says the right hexagonal prism. Hexagonal means we have a hexagon on the bottom. Prism means it doesn't come up at a point like a pyramid. We don't squish our sides in to make them come up at a point. Our sides just grow straight up. Yeah, okay. And then it says faces are parallel if the planes containing the faces are parallel. So I would say this top face is parallel to the bottom face, or this front face is parallel to this back face, but this front face is not parallel to this crookedy thing because it's crookedy. Alright, so let's see. It says name all the pairs of parallel lateral faces. Okay, well, let's see what they did. It's easier to check the answer choices. Okay, it says AF, F prime, A prime. That's how you say those little tick marks. Okay, and FE. Let me find FE. Where is FE? Where's the F? Oh, there it is. FE, E prime, F prime. So the question is, are those two suckers parallel? No, they're not. Because they're tilted. Parallel is only like that, like this, like that. Yeah, parallel. We know what parallel is. Okay? And so these two suckers are not parallel from each other. They're literally attached to each other. Okay. So A's out. Let's look at maybe B. Okay? It says AF, F prime A. Okay, so that's still this sucker. Okay, and the only thing this side could be parallel to is the side across from it. D prime, C prime, CD. Let's see, they said DC, DC, C prime, E, D prime. Hey, yes. Okay, those two are parallel to each other because they're across from each other. And they're across from each other at the same tilt. Look at those lines. They are parallel. Look at these lines. Parallel. 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 Okay, you get the point. Okay, anyway. So that's definitely parallel. Let's see if anything else had that. D, C. Let's check maybe C, because C kind of says that. Let's look at C. C says AF, F prime, A prime. AF, F prime, A prime. And ED, let's see where ED is. ED, here's E. Where's D? Oh, there. D prime, E prime. Oh, okay. So, part C is saying that this blue outline is parallel to this orange outline. And those aren't. They're not parallel to each other. Parallel means like this. So, if we're talking about this cube, the parallel sides, or the parallel faces, are these ones on the left, these ones on the up and down. They have to be across from. Okay. Okay, so C's out. Let's see. D says A, F, F, A, which is that blue thingy, and then it says B, A, B, A prime, B prime. Again, that's the front face, and that's not parallel to this tilted face, so B, yay! So remember, think of a cube, and whatever, and parallel means they're across from each other. Okay, let's see here, let's keep going. This says, name two congruent triangles. Remember, congruent triangles mean they have the same angles in the same spots, and the lengths of the sides are the same. I mean, sorry, not the lengths of the sides are the same, the angles are the same. Okay, so it says name two congruent triangles in the accompanying figure by writing a symbolic congruence. Okay. And then it's like we have to prove it out. Okay, well, let's see here. Let's make up a triangle. Okay, first, to describe the triangles, I have to have a certain order. I think I'm going to go from the right angle, V, to the next vertex of the side with that tick mark on it. That tick mark means those sides are equal. Okay, so when I label this, it's going to be VS, then T. And when I labeled that, V came from the 90, S came from the end of the tick mark line, and then T was the only other letter. Okay, so let's come up with a congruent triangle. If we're looking at this top triangle, we start in the same spot, the 90-degree angle. So, T. Then we say the letter on the line that has the tick mark. So that's this top piece of the triangle. And the letter at the end of him is U. And then my only other letter is V. Yeah. So, these two suckers are congruent. And everything has to be in the specific spot. If you can't quite see it, we can keep this left hand triangle like you see it. Okay, but let's redraw this right hand triangle. If I redraw this right hand triangle with the right angle, let's see the side with the tick mark. Well, first let's find the right angle. The right angle is now, for this top triangle, it's at T. So our right angle should be at T. The letter on the end of the line with the tick mark is U. And then the other letter is V. Okay, so let's see here. When I labeled VST, it looks like I went around, kind of like a clock. Same thing for my other triangle. I need to start at that right angle and go around like a clock. So T-U-V. Yeah. Okay, so you can either just look at your triangle or you can break it into pieces. Okay, now it says, tell whether the named triangles are congruent. Okay. Well, it says STV, and then this little equals with the squiggle means congruent. And then triangle, well, I think we kind of labeled ours a little differently. Let's label it like they labeled it. They said STV, so they started with the S and they went around counterclockwise. Okay, so STV is congruent to UVT. So this first thing says triangle STV congruent to triangle STV UVT. And this UVT and TUV, they represent the same triangle. It's just a different way of writing it. Okay, let's see here. Now it says angle 6. Remember this, or sorry, angle S. Remember that little less than symbol? It means angle. So angle S is equal to what angle? Or angle S is congruent to what angle? Well, let me maybe draw those triangles out again. Okay. That was horrible. Okay, so the question is, what is S congruent to? Well, what is S on the other triangle? S is the bottom left angle on this left triangle, so it's congruent to the bottom left of this other triangle, or U. Okay, now it says angle STV. Let's figure out where STV is. STV is STV. Okay, that means this top right. And what is this top right angle congruent to? Well, it's congruent to V, Or the way they wanted us to write it was they said the bottom left, S, the top, T, the bottom, V. So we got to name our angle V the same way. Start at the bottom left, U, go up, B, T, yeah, UVT. So this top angle is UVT. And we wrote it that way with 3 letters because that's what the prompt asked us. Okay, now it says angle TVS. Oh gosh, let's find TVS. Okay, where's T? Here's T. V. S. Okay, so it's talking about this little right angle right there. And it's saying TVS is congruent to what over here? Well, start in the spot. Same spot. VTU. Okay, now let's look at this sucker. It says ST, and that little line on top of it means line segment. So ST, where is ST? ST is the diagonal, and it's congruent to this other diagonal. Yeah. But when we label it, we say the bottom S, then the top T. So we have to label the bottom U, then the top V. In triangles, if all the angles are congruent, like angle S and U, angle STV and SUV, TV, yeah, when all 3 angles are congruent or equal, we say that their sides are congruent also. So that's why ST and UV were the same. Then SV, which way is SV? On the bottom. So that's UT on the other side. And I can put a line on top of it to show it's a line segment. Then TV, that's top to bottom, so VT on the other triangle. It helps if you redraw them instead of looking at this bad boy up here. Alright, let's look at these pictures on the right hand side. These pictures on the right hand side represent side angle side congruence, or when triangles have the same SAS, side angle side. Okay, let's look at these 2 triangles on the left. The sides that we have the same are these little 1 tick markers. The other sides that we have the same or congruent are these double ticked marks. Okay, the angle that we have the same is this angle B and angle E. Okay, when you describe the type of congruence, you go counterclockwise or clockwise. Either way, if I start at this top sucker, okay, and when we go counterclockwise, this might spell a no-no word. And if it spells a no-no word, we cross it out. Okay? So, let's try and go around. If I look at this angle, I have an angle, side, and then they gave me another side. Well, ASS is a no-no word, okay? And I want to show that the angle they gave me that's congruent is in between the 2 sides. So that's why I say SAS. That shows that the angle in between the 2 sides are congruent. Okay? If you look at this sucker, this kite. Okay, let's look. We have a side and a side that are congruent. But where is the angle they gave us that's congruent? It's this angle that they gave us. And heck fire, what does this spell? SAS. It could spell the no-no word. Or it could spell SSA. Get it? Because there's 2 S's and an A. But the thing is, this angle is in between the 2 sides. This angle E was in between the two sides. So I cannot write SSA because the angle A has to be in between the two sides. Okay, let's do an example. It says a truss used in house construction to strengthen roofs is shown below. Name two congruent triangles and tell why they are congruent. Okay, so this would be like a roof, and then there would be like really thick wooden beams going across your ceiling, but your ceiling would still go really high and be a triangle, meet at a peak, but you'd have those thick wooden beams like slatted across your ceiling. Yeah. And some of them would look like this, so you'd have another beam behind that. Anyway, okay. It's okay, it's not important. Alright, it says name two congruent triangles and tell why they are congruent. Okay? Well, let's find what they gave us that are congruent. So we have a side and a side that they gave us. Okay? Those are sides. The angle they gave us, this 60 degrees, that's an angle. And I have two triangles here. When I label triangles, I label one at a time. So let me go ahead and pull out this sucker. A, B, D. Okay, so they gave us a side. They gave us the angle B. And they gave us this angle D. Okay. In this other triangle, they gave us a side. They gave us the angle at the top, 60 degrees. And they gave us a right angle. That counts as another angle. Okay. So this could be a AAS, because the angle sides that they gave us are congruent. Okay, but either way, let's come up with a congruent congruent triangle. How about I start with the letter D. Okay, D and then go around. That would be DAB. Okay, well, let's look at this other triangle. Let me label it. Okay, we start at the same angle we started with when I labeled my other triangle. So maybe D. And then where did I go from that D? Did I go up? Nope. I went to the left and around. Same thing here. From this D, I'm not going to go up and write down B. I'm going to go to the right and label around. So we always label clockwise or counterclockwise. Either way, it's in a circle. Okay, so this sucker would be DCB. Okay, or if I wanted to go in a different direction, maybe I wanted to label B first, then A, then the right angle. So BAD. I could do the same thing on this other triangle. Let's say I wanted to label that top angle first, B. Then the C, and then the last, and then the right angle last, D. So BCD. Okay, and I could even come up with a third pair by just reordering, just picking a different letter to start with. Maybe I could pick A, and it would be ABD or CBD. Yeah. Okay, let's keep looking. Let's look at this awkward guy. Okay, well, first, let's start by labeling. Or first, let's find a point to start with. Remember, over here on the left, the very first thing I did was start at the 90-degree angle. Okay, you don't always have to start at the 90-degree angle. Let's say I want to start at this letter B. Okay, if I want to label this right-hand triangle, let's go counterclockwise or clockwise, it doesn't matter. I'll say BCD. Okay, well, when I label it, this other triangle, I'm going to start with the B, but I'm not going to say D next because my very first combination was BC on this right-hand triangle. So that means on the left triangle, it needs to be B in that same one tick mark line. So we need to follow that same line with the one tick mark. And that's our next letter we're going to write down. So, B-A and then D. Yeah. Or we could go backwards. I could say this letter D. And then C. And then that common B at the end. Or this left-hand fraction could be D, go up to the angle that's congruent to C, which is A, and then B again. Alright, let's look at this sucker. It says AAA. That's not a thing. AAA is not a congruence postulate, which means 3 congruent angles means the triangles will be the same shape, but not the same size. And when I say size, I mean surface area. Yeah. Okay. For example, I don't know if you know it, but you know there are Doritos out there. Let's say that a big old Dorito out of a regular Dorito bag has these angles. But then I don't know if you've seen it, but now they have like cylinders, like Pringles cans, and inside there's little tiny Doritos. Have you seen that? Kind of a waste of money. But anyway, so let's say you have one of these tiny Doritos. Yeah, the angles can be congruent. So this top angle might be 60 degrees on both the big Dorito from the regular bag and the little Dorito from that little cylinder that are kind of like Pringles. Okay, but just because the angles are the same doesn't mean their sides are the same. As in their surface area could be different. So AAA is not a thing. Do not pick that as an answer choice unless it's saying it's wrong. Okay, we have some more pictures. Equilateral triangle has 3 equal sides. Isosceles has 2 equal sides. And on this isosceles triangle, it has 2 equal sides, and then a scalene triangle has no equal sides. Okay, if I want to know about angles, this equilateral triangle has equal angles. Now you might be saying, hold up, you said that couldn't happen. That was something different. That was talking about if the angles are the same on different sized triangles. That does not mean their sides are the same, and it does not mean their surface area is the same. So that had nothing to do with this. Okay, so equilateral triangle has equal angles. Isosceles triangles has 2 equal angles at the bottom as the base. Okay, then for acute triangles, all the angles are smaller than 90. Right triangles, one of the angles is 90. Obtuse triangles, one of the angles is bigger than 90. Okay. To be a triangle, something has to happen every single time. 2 sides must add up to be less than the third. This is called the triangle inequality theorem. Okay, so what that means is, let's say I have 1, 3, 4. Okay, 2 sides have to add up to be less than the third. Okay, and the way we describe this triangle is we say it's a 1, 3, 4. because it has a side of a 1, 3, 4, and we put them in order, smallest to biggest. Okay, now the two smaller angles have to be less than the third. Sorry, my bad. The first two sides must be less than the third. So, let's check and see if this is right. Let's check this A plus B bigger than C. My A would be 1. My B would be 3. So 1 plus 3. Okay, and it's supposed to be bigger than C. Let's see if that's true. 1 plus 3 is 4, and it's bigger than 3. Yay! But it says it's all combinations. Okay, so when I add the sides, they have to be bigger than the other. So I added 1 plus 3, and heck fire, that's 4. That's bigger. Wait, hold on. I have to add the two sides, 1 plus 3, and it's supposed to be bigger than C, which is this left-hand sucker. I wrote this wrong. Let's try again. A plus B. That's 1 plus 4. I'm a moron. Okay, 1 plus 4. Gosh, what's wrong with me? 1 plus 4 is supposed to be bigger than the third side, 3. Let's see. Is 1 plus 4 bigger than 3? Nah, that's 5. And 5 is bigger than 3? Okay, now it makes sense. 5 is bigger than 3. Okay, let's check the rest of the sides. So we added 1 and 4, and it was supposed to be bigger than the other side, 3. And it was. Okay, now let's add 1 and 3. And it's supposed to be bigger than the other side, 4. Okay, well that gives me 4 bigger than 4. That's not true, because this doesn't say less than or equal. These are not equal symbols. This is just a greater symbol. So this would be a triangle that does not exist. It's not a good triangle. Those numbers I made up would never ever fit a real triangle. We could never make a triangle that size. Okay, let's keep using this inequality theorem. Okay, first let's do some examples. Okay, I think that inequality theorem comes up on this last sucker. And, let's see, this right here. Yeah, okay. But first, let's do this top left. It says, for parts A through J, a segment congruent to AB and an angle congruent to CAB. Okay, so through construction means you draw it with your pen and your hand. Okay, so a segment congruent to AB, that means the same length of AB. Same length of AB. Which one of these answer choices does not have the same length of AB? Not C, that looks shorter. Not A, that looks shorter. Okay, now it says, and an angle congruent to CAB. Well, let's see, where is CAB? CAB. CAB. Oh, it's talking about this little bad boy, isn't it? Yeah, that little bad boy. Okay, well, which angle looks like this sucker? As in, it needs to be pretty small. Let's see. And then let me trace this guy. Oh, okay, you can tell. This right hand, D, is way fatter than this B. It goes way higher. The side goes way higher. So that angle is fatter. Okay, so our answer is just B. So when it says construction, it means you use your pen and you just repeat what they tell you. They said a line segment AB. So I took that AB. Yeah, that's AB. AB is this length, not this tiny length. Okay, then I draw this angle. And the question is it B or D? Well, D goes up like this. You see it goes higher, so that's why that one's not the answer. Okay, let's look at part C. It says a triangle with sides of lengths 15, 20, and 25. Which kind of triangle is the correct triangle? Okay, so when it comes to triangle sides, it has to follow the formula a squared plus oh wait, no, we don't have to do that. I think we can just eyeball this. Okay, it says a triangle with sides of length 15, 20, and 25. Okay, well, if we look at part C, it has 20 and 20. That ain't right. Okay, if we look at A and B, they look pretty much the same. The only thing is where the numbers are. Well, when it comes to triangles, whatever the longest side is, or whatever the biggest number, that's your longest side. So since our big number is 25 out of all three of these, my longest side should be 25. And on a triangle, the longest side is the hypotenuse. Yeah, and the hypotenuse is the diagonal. So A is wrong because it has 20 on the diagonal. Okay, our only other answer is either B or D, not possible. So C we knocked out because it had the wrong number. It didn't even have 25 on it. A we knocked out because the biggest number has to be your hypotenuse. Now to figure out if this triangle is actually possible, we're going to do the Pythagorean theorem. A squared plus B squared equals C squared. And this Pythagorean theorem says that C is always the hypotenuse. So if we're checking this B, let's check it. We're going to have A squared and B squared can be either of the sides. So let's check. We have, let's see, it's equal to 25 squared because that's the hypotenuse. Then we have 15 squared plus 20 squared. And let's see what that makes. 15 squared is 225. Yep. 20 squared is 400. Okay, let's add those and we get 625. Okay, this will be a correct triangle if this 25 squared is also 625. So 25 times 25 is 625. Huzzah! So B is our answer. We knocked out one answer because it didn't even have all the numbers we needed. We knocked out another answer because the biggest number was not on the hypotenuse. And then we said that D ain't right because when I plugged in my numbers with the hypotenuse being the biggest number, it came out true, like the arithmetic was correct. Okay, and then it says, what kind of triangle is the correct triangle? Well, let's see here. That triangle does not have 3 equal sides because it was 20, 25, 15, so it's not equilateral. Equal sides, we don't have two equal sides, so it's not isosceles. So it must be a scalene. Yeah, okay. If we were talking about its name in terms of angles, this right triangle has a right angle in it, so it's a right triangle. Okay. Let's see. Part D is asking the same thing. It's asking, do the numbers 2, 7, and 10 make up a triangle? And it did not give us any pictures this time. But it's okay. We can still use this Pythagorean theorem. So we're going to have a squared plus b squared equals c squared. And c is always the hypotenuse, and it's always the biggest. So out of these three numbers, which one's the biggest? 10. So we got 10 squared. And then the other two numbers can go in the A or the B or the B in the A. Either way, let's write them down. 2 squared plus 7 squared. Alright, let's see what this is. Now we're going to do the arithmetic. 2 squared is 4 plus 7 squared is 49. That makes 49. And what are we supposed to be equal to? We're supposed to be equal to 10 squared. That's 100. So on the left, the arithmetic gave me 49. On the right of the equal, I got 100. Yeah, that's not the same number. So, part D, it asked us to find the triangle. Part D is impossible. If that Pythagorean theorem won't work, then it's not a triangle. Okay, let's look at E. It says an equilateral triangle with sides of 7 centimeters. Well, let's look at 7 equilateral triangle. Okay, for an equilateral triangle, I don't see a right angle in here. So, we have to use this triangle inequality theorem that says if you add 2 of the sides, it sure enough better be bigger than the third. So let's try that. If I have Wait, I think on E, it just wants you to pick the picture. My bad. On E, I think it's just a multiple choice, and it wants you to pick the picture. So, for E, you're going to pick the picture that looks like it's an equal amount of sides all the way around with 7 all the way around. My bad. I thought it was one of these Pythagoreans. Okay. F says we got a triangle with 12, 14, and an included measure of 75. And it says, is it possible? Okay, well, if I have side 12 and side 14 and 75 included, that means the 75 has to be in between the 12 and the 14. So let's find which picture looks like this. C looks like it. In between the 12 and the 14, there's a 75. Let's look at B. 12 and 14, and where's the 75? So B's out. Okay, let's look at A. I got 12 and 14, but B is not but 75 is not included in between those. If 75 was included, we would be talking about this top angle because it's in between the two sides. So A's wrong because the angle's in the wrong spot. Okay, so that means we got C, yeah. Okay, let's keep going. G, it says we have a triangle with sides 12, 14, and a not included measure of 40. And it's asking us, what does it look like? Okay, well, we need 12 and 14. Okay, and then non-included measure of 40. That means I'm not going to put 40 in between. I'm going to put 40 like maybe up here in this top angle, or maybe this right hand angle. I can put 40, but I'm not going to put 40 in between the 12 and the 14. So let's see here. On part A, 12 and 14, the 40 is in between. That's called an included angle. So this one's out. B, 12 and 14. 40 is not included because included is this top angle. So that's probably right. Okay, let's look at D. It says 12 and 14. 12 and 14. And an angle not in between them. The angle in between them would be this guy right here. Yeah. Okay, so both of these pictures look right. They have 12 and 14, 12 and 14, and the angle is not included. What's the difference between these two pictures? B says a little right angle box. Did this say anything about right angle? No. So, B's out because we don't know if it's right or not. So, the answer must be the D. Even though D looks like there's a right angle, that little box is not there. So, it could be 89 degrees. So, we're not choosing B because it didn't say anything about right angle. Okay, let's keep going. I says a right triangle with legs 4 and 8. The legs include the right angle. So that means we're supposed to have 4 and 8. And inside is that little right angle box. Okay, well, let's see. Nope, A's out. Yeah, B could be it. C, I don't even see the number 4 on there. Okay. So, B. Okay, let's keep looking. It says, for each of the conditions in the problem B through I, does the information determine a unique triangle? Check all whose conditions determine a unique triangle. Okay, a unique triangle means it exists. So, let's see which ones did not exist. The triangle with 2, 7, 10. So, everything else existed. Okay, but the question is, unique is just one angle. So let's look at this H. Okay, on H, the triangle that we picked was 8, 4, and a right angle. The question is asking, could you make any other triangle that looks like this, where the legs are 8 and 4, and we have a right angle in between them? And the answer is, yeah, we could find another angle. 8, 4, right angle. So, the triangle we drew on part I is not a unique triangle. So, H is not unique. Okay, let's look at G. On G, we labeled 14, 12, and 40 in between. Sorry, and 40 not in between. The question is, could I draw another picture with 14 and 12, but the 40 in a different angle, not in between? Well, if this is in between, not in between is up here. So that means that the triangle from G is not a unique triangle. Okay, for part F, we had this looking answer. Okay, and the question is, could you have another triangle that has sides 12 and 14 and an included angle of 75? Is there another way we could draw it? And the answer is, yeah, we could draw it a different way. I could have 75 at that bottom left, and then 14 could be at the top and 12 could be at the bottom. Because that way 17 is still included in between the 14 and 12. So what we did on F was not a unique triangle, because it can happen again if we just swap around the numbers. Okay, let's look at E says a triangle with sides 12, 14, and included angle measure of 75. We already did that. Okay, let's see what else. An equilateral triangle with sides 7M. The question is, can you make another triangle that looks different but has the same sides? As in, could I draw it a different way? And the answer is, I cannot draw it a different way, because if all the sides are the same, I can't be swapping sides, like putting numbers on different sides, because all the numbers are the same. So that equilateral triangle definitely creates a unique triangle. Okay, so when you're doing this, if you can draw it a different way with the properties being the same, then it's not unique. If you cannot draw it a different way, like 777, no matter how many times I write 777, it's still 777. So that means it's a unique triangle. Okay, let's keep going. If we look at this next sucker, it says find the measure of angle C in the following figure. Okay, well, this involves a little bit of information from the last section. We learned that these little humpy things, yeah, that means those angles are the same. Just like that little tick mark means those sides are the same. Okay, so let's talk about those angles. We have x minus 34, and it's equal to x over 2. Okay, well, let's think about this. If I want to get my x by itself, I need to get rid of this 2. So I'm going to multiply every single thing by 2. This is kind of strange. This is kind of what we did in college algebra with least common denominators. Okay, so when I multiply everything by 2, 2 times x is 2x. 2 times negative 34 is negative 68. 2 times x over 2 cancels. And we just have x. Alright, let's get x by itself. Well, first, I think I'm going to move this 60, I think I might like subtract this 2x so that I can get my x's on the same side of the equals. And I knew to subtract because that 2x was a plusative. And the opposite of a plusative is minus. Okay, so we get negative 68 equals 1x minus 2x is negative 1x. Okay? And then if I want to get x by itself, I divide by negative 1. And we get 68 equals x. But that wasn't the problem, was it? The problem was, what's angle B? And what's angle C? Okay, well, first let's figure out angle B. B is x minus 34. Or 68 minus 34 is 34. So angle B is 34. Okay, automatically I know angle A is also 34 because of those two little curvy things. Yeah, they mean the angles are equal or congruent. Okay, well now we have to figure out angle C. Well, this is where we have to use some information from the last section. How many total degrees are in a triangle? 180. So now let's subtract off the 34 angle on the left and the 34 angle on the right, and we should get 112. So this top angle is 112 degrees. Yay! Okay, let's look at this right-hand sucker. It says, congruent sides are marked on the figure to the right. Find the values of x and y. Okay, well, one thing we haven't talked about with an equilateral triangle is it has 3 equal angles. Okay, well, check out this triangle with the tick marks on it. Yeah. All those angles are equal. As in, this top left angle is labeled X. Well, this top right angle is going to be X. This bottom angle is going to be X. So this triangle has X's all up in it. And the reason it does is because the sides are the same. So that means the angles are the same. Because it's an equilateral triangle. Okay. So if all these angles are the same, that means X plus X plus X. All 3 of these angles add up to be what? 180 from the last section. So this makes 1x plus another x plus another x is 3x equals 180. Divide by 3, x equals 60. Okay, so the question was, find what x is. We did. It's 60. Okay. Well, let's see here. We have to figure out what that y is. Okay, well, let's look at this part of the triangle. This part right here. You see how angle X is this angle B? Well, we just found that it was 60. Okay, well, in the last section, we learned that one angle and another angle butted up to it that make a line. Remember, that's kind of like a horizon. And these 2 angles should add up to 180. So 60 plus something will give me 180. So the question is, what is that something? Well, that'll be 120. So this angle B is 120. Yay! Okay. The only other thing we haven't touched is this bottom left angle. Okay, here's the thing about triangles. If I'm talking about this side, the hypotenuse, the angle that matches him is the right angle. It's what's across from him. If I'm talking about the height of this triangle and I'm looking for the angle that matches him, it's opposite. So it's not this top angle, it's not the right angle beside him, it's opposite. Okay, if I'm talking about a triangle with the bottom with a tick mark, the angle that matches him is not the ones beside him, but across from him. Okay, so what that means is, let's say I have a triangle. And let's say these 2 sides are equal. That means that the angle across and the other angle across are both equal. So equal sides have equal angles. Okay, let's use that here. if we look at this equilateral triangle, all these sides have the same angle, 60 degrees. That means anywhere else I find a little single tick mark, across from the single tick mark, I draw 60 degrees. So let's look. On this right-hand triangle, oh, I see a tick mark. Well, the angle across from it is 60 degrees. Not the angle to the left of it, not the angle to the right of it, the angle across from it is 60 degrees. Okay, well,